We introduce the market model studied by Arrow-Debreu. We have M players acting in the market. We have K different commodities. Every player can have an amount of each of these commodities. For example, a commodity may be money, another commodity may be a generic good. In general, the commodities may be many. Each player has initial endowment of commodities. For instance, a seller may have only goods, while a buyer may have only money. In the picture, we have 5 different commodities, each colored in a different way. For each commodity, we use rectangles of different size to denote different amounts of commodity. Every player has a utility function defined on the space of the commodities. In particular, the utility function is defined from the space of the real numbers of dimension k to the space of real numbers. We just consider non-negative real numbers. Furthermore, the utility function is monotonically increasing and it is concave in the amount of commodity j of player I. Then we have the market. The role of the market is to fix the prices. More precisely, the market fixes a price for every commodity. Every player can carry on a transaction directly with the market. This is an abstraction, since in principle every player can carry on economic transactions with multiple other players. But this transaction can be justified by the theoretical result derived by Arrow-Debreu. The behavior of each player in the market is determined by a maximization problem. That is, basically, the best response of the player. The decision variables are given by the amount of commodities of the player. The maximization is of the utility function of the player. So, in practice, every player tries to change the amounts of commodities she has in the attempt to maximize the utility function. However, the player is subject to budget constraints. That is, the player has an initial monetary amount given by the monetary value of the initial endowment of the player, and the amount of commodities of the player cannot have a monetary value larger than the monetary value of the initial endowment. So, this is the initial endowments of the players. After the transactions, every player will have a potentially different endowment. The theoretical result of Arrow-Debreu is that there is always a vector of prices, such that the aggregate demand of the players is equal to the aggregate supplies. That is, every player acts in the market trying to improve her utility function subject to the budget constraint. This is done by selling and buying commodities. For each commodity, the amount of commodities sold by some players to the market is equal to the amount of commodities bought from the market by other players. Thus, the market is in equilibrium. Furthermore, there is no transaction that players can do to increase their utility. Therefore, the equilibrium is Pareto efficient for the players. The Arrow-Debreu model captures the case in which there is a perfect competition among the players of the market. The model describes the functioning of the market economics in which the players act independently of each other. The model is central in many theories on the market economics. The existence of an Arrow-Debreu equilibrium is guaranteed by the fact that such an equilibrium, as the Nash equilibrium, is a fixed point of a vectorial function, that one reported in the slide.